Hello, my name is Trumpf. I'm teaching in the Division of Landscape Architecture at the University of Hong Kong. The topic of my today's talk is Hands-on Online, Challenges and Learnings from Teaching Landscape Materials and Fabrication from the Kitchen Table. The learning of practical skills enabled through making and experimenting is indispensable in design education. Digital and manual prototyping is used in this context for students to evaluate different stages of their designs. Very often, prototyping methods presume an understanding of the materials used, their workability, constraints, and potential, which goes beyond properties commonly referred to in generic material specifications. In landscape architectural education at the University of Hong Kong, learning on materials was previously often investigated primarily theoretically. Recognizing this deficiency, a range of courses, amongst the here discussed landscape media seminar, have stressed the importance to create opportunities for experiencing, testing, and evaluating materials hands-on over the past 3 years. Since the submission of the abstract to this writing until today's presentation, an eventful year has passed, leading to debates on the future of tertiary education and online teaching. A year ago, the realization that this pandemic will and should have a remaining influence on our visions of landscape architectural education only slowly began to solidify. This presentation will cover the learnings from experimental working with materials, starting from conventional classroom education in 2019 to the setting up of home fab labs in March 2020, resulting in the current initiative of the Tall Materials Library. The here described landscape media seminar is core to the postgraduate diploma in landscape architecture, PDLA, a new one-year degree for students who do not yet have training in the design fields. It is intended as a preparatory degree for the Master of Landscape Architecture MLA program. The course introduces essential digital and manual tools for design and representation in landscape architecture. Students explore techniques in material testing and digital fabrication as an iterative part of the design process. First efforts to structure this course were initiated to tackle superficiality of specifying materials. The fact that we can see hardly newness in students' projects in terms of material innovation is little surprising looking around in the urbanized areas of the city. Many of Hong Kong's urban landscapes are dominated by unimaginative hardscapes with little attention to design site specifically and taking into account concepts of sustainability, fabrication, and construction practices. To frame this course, a leading question was, how can we teach construction materials in an elaborated and landscape-specific way? In the first iteration of this seminar in 2019, students were asked to work with typical materials, such as concrete, resin, wood, or aluminium. All materials were introduced along with the university's workshop facilities. Following a short design exercise, students experimented within that predefined range of materials. They learned about workability of materials and tools and executed one-to-one prototypes. But there was little exploration and experimentation beyond the set brief or instructor's suggestions. After a reflective discussion with students of this cohort, material testing and experimentation was front-loaded and the number of in-class workshops giving practical instruction increased. These workshops around materials and digital technology were structured to provide sufficient guidance on foundational skills from the teacher's side, but also to allow for more room for experimentation and feedback from fellow students. Peer-to-peer learning is particularly valuable in this program with students of different expertise. The approach of multi-layered feedback was aimed to equip students with transferable skills to be applied in this course as well as in their studio projects. The process-oriented learning incorporates an interplay of thinking and doing with classes structured to allow students to test and apply their gained skills and knowledge instantly. The better understanding and extended time frame to learn about both materials and tools was projected to increase the willingness of students to undertake more speculative material experimentations in future course iterations. In Hong Kong, the transition to pandemic-related online teaching started already in January 2020, only 1 week into the spring semester. In this first stage, ad hoc adjustments were made reacting to the weekly updated recommendations from the Task Force of Infectious Diseases. After 2 weeks of class suspension and the first trials of Zoom classes, teaching was switched entirely to online mode around 4 weeks into the semester, and courses with requirements to use the university facilities needed to be adapted. The learning benefits demonstrated in the 2019 cohort of this seminar were the decisive factor to carry out the material diaries exercise without physical access to the fabrication labs. Students were encouraged to set up home fab labs with minimal means to manifest and facilitate learning through the immediate approach of crafting. The adapted course brief restricted material sourcing to supermarkets and neighborhood hardware shops, asking to compose materials suitable to potentially fabricate objects designed in an earlier exercise of this course. The resulting DIY materials established a new layer to the design work of the students and transitioned the learning about materials from simply following practical instructions to generating their very own material experiences. DIY materials, as defined by Rognoli, can be totally new materials or modified or further developed versions of existing materials. To enable this prompt creation of materials, students tested online recipes or modified existing material studies to suit the local context. The very local availability of resources increased the variety of materials explored with students suddenly located all over Asia. At the same time, locally varying outcomes of similar experiments resulted in a wide range of different observations and enabled conversations in the virtual classroom about the influence of the lab setup, as well as the environmental factors such as relative humidity and temperature on the material behavior. While, for example, a bioplastic experiment with comparable ingredients and setup would achieve satisfying outcomes in Taiwan, the samples in Indonesia would mold almost overnight and before the mix was properly cured. Test setups imitating those of applied science environments were used in this course as a tool to inform and describe design processes. Material failures, challenges, and confusions which accompany this process were summarized in the material diaries and other graphic reflections, and made available to fellow students. The exploration of these extended material qualities unveiled in this exercise was used to discuss and understand wider concepts of sustainability, urban resources, as well as fabrication and analysis technologies. Students assessed their design decisions based on the adapting conditions and speculated on how to reintroduce these mostly atypical materials to potential landscape projects. Critiques on architectural and design education state that curricula were gradually transformed through the inclusion of scientific content, losing part of their traditional hands-on educational methods. 100 years ago, materials education at the Bauhaus, particularly in Johannes Itten's basic course, was focused on visual and tactile descriptions of material properties. Building on this foundation, the prevalent understanding of materials in light of emerging modern technology at the time questioned the value of handcrafted versus industrial precision. The aim of materials education at the Bauhaus was to reveal techniques and production processes that lead to the development of prototypes with new applications for production. Today, we once more have to question our understanding of materials. Not only are we talking about composite materials, smart materials, and nanomaterials, but we must also understand material dependencies on land and people. So beyond considering the crafting approach, we must ask, how do we classify materials? How should we specify materials? And when is a material sustainable? In the currently taught 2021 cohort, the brief for the material diaries exercise was once more adapted and opened up to allow students to define their own working guidelines. It aimed to cover a wide range of research possibilities on a specific material, which could include topics like embodied energy, CO2 footprint, or collateral pollution. The brief is open-ended for the prerequisite material research as well as for the setup for the experiments itself. Meanwhile, the course is taught in hybrid mode. General brief introductions and lectures are still online, but small group meetings can be offered in studio, the workshop facilities, or outdoors. Online tutorials to introduce material testing and tools, as well as guidelines for a voluntary home fab lab, were provided to the students. This time, the introduction could be complemented with short workshops at the university facilities. As a result, students showed a wider range of materials, yet the focus shifted away from the iterative testing on DIY materials observed in the online version of the course. Students extended on desktop research, chose rather typical materials, and focused on the availability of digital tools during this semi-distant learning. After summarizing the learnings and challenges to run this and other courses in the Materials and Technology stream over 3 years with varying proportions of face-to-face and online teaching, 2 directions can be summarized. First, material testing influenced by trial and error should be accepted. The learning structure of this course must be situated between exploratory and scientific, suggesting students to work with semi-structured experiments. Second, outcomes and material testing must be self-evaluated by the students. This should be structured by teachers to facilitate opportunities for vertical learning between cohorts. The aim for a vital materials pedagogy is to facilitate students with a greater understanding of material knowledge and its application, including concepts of sustainability, fabrication, and construction practices. In recent years, a variety of teaching and research tools working with materials were developed in design-related disciplines. But for landscape architecture purposes, many existing resources, online and physical libraries, fall short. Many available databases are geared primarily toward architectural material usage and are stocked with materials more readily available in North America and Europe. Their classification systems consider a variety of taxonomies but leave out important factors for landscape architecture. Many concentrate on typical properties like material category, form, sensory attributes, where other examples are considering subjective material evaluations or are connected to makerspaces. Students at the University of Hong Kong may access parts of the available information, but cannot gain the benefit of actively engaging with the resource, for instance through manipulating the database. Resulting from the analysis of these shortcomings, and along with the ongoing effort to shape the materials stream of the landscape curriculum, I developed together with my colleague Ivan Valen a framework for a new landscape-specific materials archive called TAL. TAL describe the 3 facets of the library: taxon, archive, and lab. Each of these facets is both a reference and, through their design and organization, a multi-year learning opportunity. Taxon describes the landscape-specific organization based on a material's origin, ecological properties, production, processes, durability, and sustainability. These categories provide a conceptual scaffold for students to understand and design with materials in a systematic way. Archive describes the collection of physical and digitized material samples, including found and manipulated materials and their variations. Data includes textual, visual, and graphic representations of the material, as well as information on its properties, performances, form, and procurement. The lab is the experimental arm of the database and will encourage material experimentation as a basis for systematic environmental design and facilitate testing and other forms of analysis on manipulated materials. This component is particularly important for the landscape media seminar. It will allow students to understand and follow experiments and testing of earlier cohorts. They can comment, edit, and manipulate earlier entries. It is the function of the lab to synthesize methods for working with materials and create opportunities for students to reach out to other university research laboratories, as well as seeking collaboration with local practices. Part science, part system, and part making, this library aims to develop new techniques for working with materials in landscape education and capture newly emerging technologies for regional materials. As we have learned in 2020, pedagogies depending on hands-on and experiential learning should be designed to incorporate online modes of teaching and learning and be flexible to multiple modes of access. TAL emphasizes the setup as a digital platform, partially as a response to a continued focus on online teaching, and partially as a recognition that student design and research workflows rely heavily on digital modeling and simulation, a trend that has only increased over the past year. Meanwhile, educators around the globe have responded to teaching modes during this pandemic and are predicting how learning will be transformed afterwards. The opportunities in this forced worldwide shift to teaching online are evident and widely discussed. But likewise, the critique of this mostly reactive teaching mode should be heard and considered. Particularly in design-related fields, teachers recall the value of face-to-face practical instructions and the physical output of design work. Critical voices ask if the sensory deprivation of online teaching will be the new normal, and call for strategies to shape and deploy all the new technologies and platforms. We clearly acknowledge the shortcomings of online education and the absence of practical instructions, but emphasize on the opportunities of an online resource as relevant and robust tool in materials education. In a time when all forms of teaching and access to resources are being reconsidered, we recognize the value of flexible teaching resources ready to provide effective opportunities for blended learning. The core idea of this yet-to-be-implemented database is structured around engaging students with a resource, physically and virtually. But following key components can only be achieved through the digital archive of TOL. 1. Student experiments can be documented, tracked, and evaluated. 2. Material experiments and their individual components can be searched through a variety of filters. 3. The database allows students to directly manipulate entries of previously tested specimens and propose to develop them further. TOL Materials Library will be incorporated in a range of courses which can benefit from the database as a learning resource. For the Landscape Media Seminar as a core course in the PDLA program, I can summarize following learnings and future prospects. 1. Practical instruction is crucial to provide learners with basic information before starting the testing on materials. Lectures might be less efficient, but a study of existing samples helps to start students' own material tests on a more informed level. This justifies the importance of documenting experimentation and testing of students across cohorts. 2. Remote access to a variety of materials and previously undertaken tests is important. This is particularly true for DIY materials which often need various iterations and references before being developed into functional samples. The Landscape Media Seminar is commonly the first course to introduce materials as the program intakes students from non-design related disciplines. It is hoped that learnings from this course enable students to extend research-based learning and material experimentation, material performance simulation, and other forms of one-on-one prototyping. In future, we aim to provide students with opportunities to interact with professional practitioners or material engineers through the research, maintenance, and experimentation in the TOL Materials Library.